Have you guys heard the word parallel or perpendicular before?
Yes.
Parallel is what?
Parallel is like two straight lines.
All right, you're showing me with your hands.
Two straight lines.
Jesse, explain with words. Good job.
Good job, John Sear.
Parallel lines not only never bump here, but they will never bump for infinity. Never intersect is what we like to say. Yeah.
Good job, Job.
They are intersecting. All right. All right. This is chapter 4, lesson 3. Guys, y'all stay with me. All right, parallel lines go on and on forever, and nowhere ever in the world will they ever touch or intersect.
Unless
they're
not parallel.
Unless they're not parallel. But parallel lines will never touch, okay? Perpendicular lines, however, will touch one time, and when they do touch or cross, or the correct word we like to use is intersect, when they intersect at 90 degrees, a right angle. Okay, so they're very special lines, right? All right. So these two lines are also special in what we've been dealing with, okay, which is slopes. Parallel lines always have the same slope. Always. They might start at different places, like their y-intercept, but they always have the same slope. Okay? And it makes sense if you think about it. If this had, let's say it had a slope of, let's say 2 over 3. I go up 2 over 1, 2, 3. This one's going to go up 1, 2, and over 1, 2, 3. They're never going to touch. They're always going to be moving up and over the same amount, so they're never going to touch. Okay? Perpendicular lines, however, when I think about their slope, they are what we call negative. These slopes are negative reciprocal. So let's think about what this means. I say negative, but really what I mean is opposite sign. So I'm going to put that in parentheses. Opposite sign. Okay? So if it starts out negative, it becomes positive. Okay? And what does reciprocal mean?
The opposite.
Flip. Somebody said it. Flip. It's opposite in every sense of the word that you can get. You change the sign, you flip the fraction. Okay? Switch and flip. Switch and flip. Yes? So, for example, well, I'll give you just a second. Copy that down, then I'll show you.
Oh, this will come for me a lot.
All right, let me draw these a little bit differently so you can see. If these are perpendicular, okay, let's say I told you that the slope of this line right here, do you think it'd be negative or positive? Why? That's right. Why would it's going downhill? It looks down here, right? Let's say I told you the slope of this line was negative
4.
1/2. What do you think, knowing, and by the way, this little square tells me that these two lines intersect at 90 degrees. What do you think that would tell me that the slope of this line is?
1/2. 5.5.
Think about what I told you. What does it have to do? What flips? Yes.
2 over 1.
2 over 1. So it's just 2.
I knew it.
Okay. See what we're doing here? All right. So let me tell you how you're going to use this. Let's say I told you to write an equation of the line that goes through the point negative 3, 5 and is parallel. And I'm going to start using this symbol for parallel. Does it make sense why I would use that symbol?
Yes, because
It looks
those
like two
lines
parallel
are
lines,
parallel.
right? Okay. And parallel to y equals 2x minus 4. So y'all copy that down just a second and then, all right, let's word this a little bit differently. Let's word this in a way that makes a little more sense to us. So tell me before we start, through a point, I'm used to having that, right? We've had it like that. But if I say parallel to this, tell me what that means. What does that tell me?
It's going to be the line. It's going to be the same slope.
It's going to have the same slope.
But it's just going to be either
So-
further down or further up.
Okay, so what is the slope of that line? Y equals 2x minus 4.
2.
Put that up. Did you just take a picture of me? What'd you just take a picture of?
Dude.
What is the slope of that
2.
line? 2. How do you know?
Because it says it.
So let's write this in the way we're familiar. Write the equation of a line that goes through the point negative 3, 5 and has a slope of 2. You have a point and you have a slope. What form should I use to write the equation? Point slope. If you have a point and a slope, the easiest thing to do is point slope. And if you need it in another form, it's easy to get to another form from point slope. So if I do point slope, what's it look like? Y minus 5 equals 2. So what is minus negative 3? Plus 3. Did I tell you what form I wanted the line in? No. So guess what? I can stop right there. Okay? If I don't tell you what form I want it in, stop right there. What if I say, write the equation of the line in slope-intercept form? Would you still start in this form? I would too. It's easier that way, right? How could I get this in slope-intercept form though? Distribute, all right? So I got y minus 5 equals, and now what? Add 5 to both sides. That's exactly right. Because slope-intercept form gets y by itself. See how this is really kind of the same thing we've been doing? It's just the only new thing is understanding that parallel have the same slope, perpendicular have completely opposite slopes. Flip and switch. Let's do another. We're just writing equations right now. Write the equation of the line that goes through the point. I'm going to make this one a little bit harder. Through the point negative 4, 6.
You gotta do that.
And is, what do you think that symbol means?
Perpendicular.
Perpendicular. That's the
Because it's
symbol
upside
for
down, too.
perpendicular. Okay? And is perpendicular to 2x plus 3y equals 12. Why is this one a little bit harder?
Because it's in standard.
It's in standard form. They're all on the same side. I know I need the slope from that, but it's a little bit harder to get the slope from here, right? Harder to get the slope because it's not in slope-intercept form. I can't just get that slope out. Okay, so that's the question. What would you do? How would you find the slope here? That's what I need is slope. That's exact. Subtract which one? I would move the 2. Get y by itself. Get y by itself so that you're in slope-intercept form. So move the 2x. So 3y equals negative 2x plus 12. Now what? Divide by 3. So I did all this. Remember, I wanted the slope. Negative 2 over 3x plus 12 divided by 3 is 4. What is the slope of that line? Negative.
2 over 3.
Negative 2 over 3. So now, can you write an equation of a line? Here's your point. Is this the slope I need? Close. If it's perpendicular, then my new slope is going to be what? Positive what? 3 over 2. Change the sign, flip the fraction. Change the sign, flip the fraction. You got to, everything you can change, you change. Flip and switch, flip and switch, flip and switch. Okay? Write the equation of the line now. Now you've got a point and you've got a slope. Parallel stays exactly the same, perpendicular, flip and switch. Write the equation. Y minus 6, good. 3 over 2, that's the slope. If I'm not asked for any particular form, then I can leave it just like that. If I am asked for another form, let's say point slope, let's say slope intercept, what can I do? Okay. I have y minus 6 equals plus what? 3 times 4 is 2 times 1 is 12 over 2 is just what? 6. I'm going to do this just so I don't have to write it another time. Now get y by itself. Three over 2x plus 6. Now look at my original line. Oh, 12, I'm sorry. Thank you. Look at this line and this line. Are their slopes opposite reciprocals? Do they switch and flip?
Yes.
Yes. So I know that they are perpendicular. Does that make sense to everybody? No?
No, I'm not sure.
Okay, let's do another one.
Wait a minute. Oh, I did.
Oh my goodness, David, that was nasty.
I tried to cover my mouth.
Did you though?
Yeah, I hope. No.
All right, let's do this one. Do you?
Honestly, I might. I'm being serious. I'm I don't know who I got it from.
Let's do perpendicular to the line. There. Remember, our goal is to find a point and a slope, and we have a point, right?
Something like that.
I have a point. Well, right now, it's hard to see the slope, right? Since this is in standard form, I need to solve it for what? Y. How do you get y by itself here? Subtract 3x. That's exactly right. If you get confused on any particular step or why we're doing it, stop me, okay? All right, so I got negative 3x plus 12. That's exactly right. Really, will somebody grab that same as McGee's room, please? Really, if it's a whole number, you put it over 1, and it's going to make, Miss McGee's room, it's going to make flipping it a little bit easier. All right, so here my slope is negative 3, right? What would my new slope be? Yeah, Elizabeth.
Huh?
All right. So this is negative 3 over 1. What would the perpendicular slope be? Anytime you have a whole number, you can put it over 1. 1 over 3, positive 1 over 3. Let me ask you this. Shh, shh, shh. What would the parallel slope be? Negative 3 over 1. It stays the same, right? Or negative 3. Goodbye. Does that make sense to everybody?
Yes.
When you have perpendicular lines, take the slope, whatever that slope is, change the sign, flip the fraction every single time. So if I started out here at negative 3, then the perpendicular slope would be 1 over 3. The parallel slope would stay the same. Y'all with me now?
Something like that.
All right. Perpendicular, that's what I'm looking for. So this is the slope that I'm going to use. So now this is just like last night's homework. Write the equation of the line given a point and a slope. Y minus what? 7 equals 1 over 3. Remember, I'm going perpendicular on this one. 1 over 3 times what? X minus 4. Okay? This one is a little bit harder to get into slope-intercept form if I needed it in slope-intercept form because of the fraction, but we can still do it. Oh my goodness. You don't have to be so just exasperated with
Oh,
this.
no, I do.
What?
I do have to be so exasperated.
What's 1/3 times 4?
Exasperation is what?
Exasperated.
I'm just not even gonna say it.
All right, here's why this one's harder to solve for y. I've got these two fractions, and to that negative 4/3, I need to add 7. All right, so let me show you what I would do, especially if I were on the EOC and I needed to do this and make sure I got it right. If you do negative 4/3, so fractions always go in parentheses, negative 4 divided by 3, and I needed to add 7 to that, right? I want that in a fraction, so what do I do? Math, enter, enter. 17 over 3. So I got 1/3 x plus 17 over 3. We'll do a problem from your homework with you.
I don't have a book.
This is number 3 in your homework. And so it's a word problem. And it says that a garden in the shape of a quadrilateral with vertices A, B, C, and D, 3, 4. And it gives me this lovely little graph. And it says that this is D, and this is B, and this is A, and this is C. Okay. It says that 2 pathways represented by AC and BD cut across the garden. And it says, are the paths perpendicular? You cannot just look at the picture and say yes or no. For one, the way I drew this is no. It's definitely no. But what tells us if it's perpendicular or not?
If the lines cross.
It doesn't cross. It has a
No, that's
How can I show algebraically? Algebraically, not the slopes. David, you're on it today. The slopes. To determine whether or not lines are parallel or perpendicular, and make a note of this, you have to show their slopes. Okay? Every time. That's the only way to show. So the first thing I want to do is find the slope of this AC. How do I find the slope of line segment AC? That's exactly right. Now I'm backing up 3 or 4 lessons, right? When we did slope and rate of change, remember that was chapter 3. You see why we're putting these sections together like this? All right, so from A to C. So I'm looking at A and C. Set it up. Subtract the y's. What goes on top? 1 minus 7 over negative 2 minus 5. All right, 1 minus 7 is what? Negative 6. And negative 2 minus 5 is negative 7. And a negative divided by a negative, I know, is a... If these two segments happen to be perpendicular, what should the slope of the other segment be? Close. Negative 6 over 7. If they are indeed perpendicular, then whenever I find this next slope between this point and this point, it will be negative 6 over 7, right? Flip and change. All right, so let's find it. Negative 3 minus 4 over 3 minus 3.
Wow, I found it.
Ooh. Did I write the problem wrong? Oh, this should be negative 3 right here. Sorry. Change your D to negative 3. All right, so up top, what is negative 3 minus 4? Negative 7. What is 3 minus negative 3? 6. Are they perpendicular? Yeah, look. 7 over 6. Oh, are they? No, they didn't flip. They have to also flip. Does that make sense? So no, right. So see how even maybe they look perpendicular, but they're not actually perpendicular. All right.
Oh, I got this really cool alarm clock.
Oh,
What?
why did we flip that
I
over?
don't know.
I don't teach that.
Some reason.
6 over 7. I just sat here and flipped it. Nobody told me any different. It's positive. My eyes are crossing on me up here. Yes. So yes, they are perpendicular. Yes, yes. I'm sorry.
I mean, yeah, they're obviously perpendicular. Look at them.
No, you can't just look and tell, because they could be off. What if they were like 89.999 degrees and not 90 degrees? They wouldn't be perpendicular. The slopes would show it, but the degree wouldn't. So you got to be very careful. I apologize, y'all. They are. I don't know why I flipped that thing over. I can't believe nobody said, Miss McGee, why'd you flip that slope over? All right.
Homework.
Fired with pay or without pay?
With